The story I was going to talk about is, as the agenda outside predicts, it talks about fleet migrations and it talks about remote connectivity. But really the subject I want to talk about is just a little bit broader than that. And that's not the slides. Anyway, I'll continue while you find it. The topic is a little bit broader than that. It's really about the rapid evolution of control systems as we see it today, and all the considerations that we have to take into account now that we didn't have to take into account just a few short years ago. And because of all these considerations, these new considerations, it's really a story about collaboration. While he pulls it up, I'll just continue. It's labeled Fleet Migrations 2. But to frame it, I'll tell you a little bit about myself and the company I work for. I work for Air Products and Chemicals. We're an industrial gas supplier. We supply industrial gases and other chemical compounds into nearly every segment of business. And the company itself is divided up into kind of three divisions. We have a merchant gas division, a tonnage division, and a performance materials division. The merchant gas business, you may be most familiar with our brand name. You see our tankers on the highway at times, and here's where we deliver product to our smaller volume users. And we deliver product like oxygen, nitrogen, argon, CO2, helium, and hydrogen. And these will get delivered in either in tankers, like you may see here soon, or in dewars or in cylinders. That's good. Go ahead and pass that slide. Okay, great. Our tonnage business is when we have customers that have higher demands. In these cases, we'll put one of our plants adjacent to the customer's plant, and we'll provide product either over the fence line or into a pipeline where they can draw from it. And those products are typically CO, hydrogen, nitrogen, oxygen, and syngas. And we also have a performance materials division. They make chemical compounds that go into other chemicals, things like products that go into polyurethanes, into epoxies, and into adhesives and personal care products. We also have an electronics material division. They make things like silane and NF3 that go into chip manufacturing. Now, Air Products engineers and builds, owns and operates their own facilities. And they also provide lifetime support for those facilities, life cycle support. And that's where I come in. I manage a process controls engineering team. That team has about 40 talented engineers, and our scope of our services are really the control platforms, the code within the platforms, field instrumentation, final elements like control valves, analyzers, and interfaces. So, to go a little bit more granular, Air Products owns and operates 750 facilities. We operate in 30 countries, and we're big proponents of having, because of these numbers, we're big proponents of having alliance agreements, standardization, and partnerships. And we have partnerships with our major suppliers, our control valve suppliers, our DCS systems, people like Siemens, people like ABB. And, but even though we're big proponents of standardization, when your plants span multiple decades, it's inevitable that you'll end up with several suppliers of equipment. And so our challenge is to support 5 major suppliers of DCS platforms, several versions of those platforms, and with the Internet of Things, to make all those things talk up to an enterprise level. So, back on topic, when we're talking about doing fleet migrations, migrations in general are painful. They're painful for even someone doing a single instance of a plant or a single instance of a complex plant. But when we're doing fleet migrations, that we're going to be disruptive on dozens of plants, if not hundreds of facilities, for any campaign that we may choose to run. So there has to be business drivers to persuade us to go ahead and want to do a fleet migration, because we don't make money migrating. We don't make money changing control platforms. We're focused on making molecules. So let's look at some of the business drivers that may cause us to do a fleet migration. The first one may be contracts. Typically, Air Products engages in 15 to 20-year contract runs. So as we approach the end of a contract run, we go back and look into that facility, mechanical equipment, electrical equipment, and control systems, to see what we have to change such that the next 15 or 20 years will be as reliable as the previous 15 or 20 years. We may also choose to do a migration because of obsolescence. We could be in the middle of a contract run with somebody, and there may be a product or a component within our plant that is declared end of life and forces our hand to do a migration at that point in time. Now, products that may have a big footprint out there may be options, third-party suppliers or something like that. But when you get into a system that may have a smaller footprint, then it would persuade us to consider a migration. A case in hand in there is that we were big users of the APAC system. It's a great platform. We had a long run with it. We have 50 plants that run on that platform, but it's declared end of life. So now we know that within the next 5 to 10 years, we have to do something about those 50 plants. We may also choose to do a migration to get a hold of a functionality. There may be a feature in a new platform that we think will bring business value. Case in hand is we upgraded about six of our batch process plants because we wanted to take advantage of the newer programming coming out. We wanted to take advantage of the sequencing and taking advantage of recipes that we could share between plants that made similar products. We may choose to do an upgrade to get up to an enterprise level. A good case in hand is remote connectivity. This conference much is about remote connectivity. And we had an instance where, we'll talk about in a few minutes, where we needed to move scores of plants up to the enterprise level and have connectivity with that. Well, many of our plants were still running on proprietary systems, proprietary HMIs that didn't play well with Microsoft and with the internet. And finally, we may choose to do an upgrade or a migration of a fleet to comply with industry standards. Two that come to mind is that we've had to do ones. Recently, we upgraded ABB's 800XA system from 5.0 to 5.1 to take advantage of alarm management tools. 5.1 had a much richer set of tools, and it allowed us to comply with some of the standards like ISA 18.2 coming down the road. We've also migrated plants, as this conference is centric on, because of cybersecurity, ISA 99. So we're trying to comply with those standards as well and trying to patch up some of our vulnerabilities. So, previously, when considering these migrations, we lived in a simpler world. The control systems group I was part of was well defined. If we wanted to do a migration, we had a simple set of things we had to consider, at least on the HMI side. And once we entered these, we would be set up to go ahead and do the engineering. To things like how many operators were going to be in the plant at any one time, how many people were going to be on the board. Are we interested in having standalone consoles, or are we really looking to have client servers? What was the complexity level of the graphics that we were looking at the time? What were the number of tags, tag count, and last, but what was the budget to do this work? And then we could go off. We could go off, and we really didn't have to talk to other groups of engineers or other people. We knew what we had to go, and we could execute it. But things have changed. So near the end of this simpler time, anecdotally, I had a visit from my boss. And he came in and tried to paint the world as he saw it and felt compelled to tell me how control systems engineering, our group, was different than the other engineering disciplines that he cared for. And so he went on to describe mechanical engineering at the time. He said mechanical engineering, a centrifugal pump that we're buying today was very much like the centrifugal pump we bought 40 years ago. Materials have changed a little bit, seals have changed a little bit. He goes, but today's pump was really your father's pump. He made the same analogy for electrical engineering. He kind of said that he saw that, although there's a lot more bells and whistles, there's alarming, there's monitoring, but switch gear, disconnects, motor starters were still relay-based, and that it didn't change a whole lot over this period of time. But then he went on to talk about us. He goes, the control systems world is just rapidly evolving. He goes, seemingly every day, new features and new components are available to us. And the challenge to him was, he says, our group, the control systems engineering team, were poised to make the biggest impact to the company than any of the other engineering disciplines. So I'm not sure if this is a motivational speech he's given us or if he was challenging us, but it was certainly the message he got across. And so we were trying to think, well, all these new features, which ones are we going to pick? What are we going to focus on first? And we've already been doing, MPC like everybody else, and we're doing remote I/O like everybody else, and we're trying to cut costs. But certainly the Internet of Things, certainly the connectivity that provided, the remote connectivity features that were coming out was one that we targeted. We said, how can we can take advantage of that? Now, we've had remote connectivity for 30 years, via dial-up or via PC Anywhere or whatever it was. But all those instances were single instances. It was one engineer to one plant at a time. I mean, we could get to anybody, but it was one-on-one. So we're saying, well, how can we take advantage of this now and do it at a much broader scale? And so what we were interested in doing was having a remote operating center. And in having a remote operating center, it was connected to hundreds of facilities at the same time. And we built 9 of these. We built 4 in Europe, we built 4 in Asia, and we built 1 here in the US, down in Texas. So the one we'll talk about the Texas one for just a second. That remote operating center is connected to in excess of 200 plants. And in those plants, we do either full monitoring or full remote control to manned and unmanned sites all the time. And for the company, this was a bit of a game changer, much like the video called out in the beginning. It was a bit of a game changer in how we were about to do business and how we're going to do business going forward. So in this previous world, we could go off in isolation with a bit of that or the little bit of data we had there and go and engineer a product. Now we fast forward to today's world. I'll go back for a second. This is just 2 pictures. The one picture on the top is 1/4 of our remote operating center in Texas. It's a oval shape. It has 4 pods. That's one of the pods. And down below is a different remote operating center. So anyway, now we're fast forward. We're going to look at how we engineer a plant today, and knowing that we want to have this remote connectivity. Well, I still have the same concerns as before. I still have the same subset of information I need to go ahead and do the engineering, but now I got new concerns. Right? I have to know, is this going to be connected up to the enterprise level? Is this going to be connected up to a remote operating center like I'm showing you? If it's doing any of those things, now I have cybersecurity concerns. So now I have another set of questions. Right? Am I going to have remote domain servers? Am I going to have local domain servers? Are we going to execute policies in work groups? Who's going to do my antivirus patching and how are we going to do it? Who's going to do and who and how are we going to do disaster recovery? And where are we going to store those images? They're going to be local, they're going to be remote, they're going to be network drives, Microsoft updates, things like that. So it exposed a whole set of questions and therefore skills that the team of engineers I have weren't equipped to answer. So I'm kind of a fork in the road. Do I take the 40 engineers who are process engineers who typically are focused on distillation control and 3-ohm and drum level control and things like that, and they're very good at it. Do I take them offline and get them Microsoft certified? Do I take them offline and have them acquire all these skills and then stay current with them? Or do I look to the IT group? Well, the IT group was sort of an obvious solution, but they had deficiencies as well. They weren't used to operating in a plant computing environment. They weren't used to the nuances of things like downtime and sensitivity to trips and a lot of other that. They were accustomed to the infrastructure. They were accustomed to the 20,000 personal computers we have in the company, and we're working in an office environment and how to dispatch programming. So they had gaps as well. When we had gaps, our gaps are here. They had gaps about working in a plant environment. So what seemed to be the best compromise of the two was to take a subset of the IT group, work with them every day, hand in hand, in a plant environment, and acquire those skills that we thought were lacking. The sensitivities to being on a plant that has to run 24/7, 5 years straight. So we created the controls IT team. And now they provide a number of services for us that are terrific. I mean, in the past, if we had to rebuild a console from scratch, a base load, it would take us days to do one. This team now has work processes and things like that where we can, if a machine fails somewhere in the world, we can have it loaded and out the door in 4 hours. So they do the initial system loads for us. They do front-end decisions like how many servers do we need, what types of servers, do we have web clients, do we have historians, are historians local, are historians going to be centralized? They continue on with, they work with our vendors and navigate through options about connectivity. Are we going to focus on web connectivity, remote desktoping, things like that? They do testing and simulation for us. They'll sit there and put the system on a live network. They'll apply latency, packet loss, bandwidth analysis, and come up with a system that's robust enough to run an enterprise remotely. They provide our firewalls. They poke the proper holes through them. They do all about PC hardening, locking down ports. They handle our backups. They work collaboratively with us on our cyber policies and also how those cyber policies are going to be distributed. Authentications, digital certificates, rights and privileges, and auto updating. They handle our disaster recovery program. They spare for us, and they do our patching. And so what it did for us, what we felt good about, was that we let both teams, both the process controls engineers and the IT group, do what they do best. The controls team I have can continue to focus on being controls engineers, and the IT group, and specifically the controls IT group, can provide these services for us and let everyone do their job. So looking forward, what do I see? I see the continued emphasis on data, and data up to the enterprise level, condition-based monitoring like we just talked about, providing things like dashboards for the managers with KPIs that are easily to see across a fleet of plants. We're doing a lot more condition-based monitoring. We're digging into not only machinery and plants, but we're looking all the way down to, we're extracting acyclic data on control valve and stiction and devices like that and getting real-time information. I see cybersecurity heavily influencing our architecture. And before, or now, or previously, it was more of a bolt-on. We bought our system, we built it, and then we said, oh yeah, we got to make it secure. But now cybersecurity is much more in the front-end decision on how we're going to architect our plants, how we're going to do our networking, and that's only going to increase. I see external agencies continuing to apply rule sets and influencing what we do. Examples of that are the cybersecurity policies. We're seeing agencies like OSHA interested right now in enforcing alarm management, enforcing ISA 18.2, and I expect the people to be audited by that in the very near future. We see other agencies like the DOT certainly influencing plants that fall under their jurisdiction. They're applying control room management policies and auditing people on those policies. I see business and operating models changing all the time. I saw our products change when we could provide them something like remote operating centers. And I see them being flexible and looking for that work. And I also see a continued appetite for innovation. So as we see new features coming up, we saw remote connectivity maturing, and we see other features up. I think they're looking to us, looking to the controls community to provide an impact to the company. Thank you very much.